Hello everyone, welcome to Java Learners. In this video, we will learn what are switch expressions and we will also learn what we can achieve using the switch expressions which we cannot achieve using the traditional switch statements. And we will also learn about the pattern matching for switch expressions. Let's learn about switch expressions. These switch expressions were released in Java 12 as a preview feature, but later in Java 14 it became a standard feature. The switch expressions provide a more concise and expressive way to handle multi-way branching compared to traditional switch statements. The switch expressions are concise as they eliminate the boilerplate code like break statements which are used in traditional switch statements to exit from the switch. In the switch expressions, we can combine multiple case labels, and that is also going to make switch expression more concise. Here, expressive means that the switch expression is easy to read and understand. The switch expressions can return a value while the traditional switch statements cannot return any value. If we want to return a value in case of traditional switch statements, then we have to declare a temporary variable, and in the case labels we have to assign the value to the temporary variable, and then when we exit from the switch, then we can return that temporary variable value. In this video, we will cover following topics. We will understand what is arrow syntax and how it can be used to reduce boilerplate code. In the traditional switch statements, it is optional to define the default case, but in case of switch expressions, it may or may not be required. It will depend on the context. If we are covering all the possible values, then we do not need to define the default case. If we are not covering all the possible values, in that case we have to define the default case. In the switch expressions, we can group multiple labels and we will see how we can group them together in switch expressions. These switch expressions support the handling of null values, and we will see how we can define a case to handle null values. At the end, we will also learn about the pattern matching for switch expression. This feature was released in Java 17 as a preview feature and it was finalized in Java 21. There were features which were released as a part of this pattern matching for switch expressions feature, and those features are type patterns, guarded patterns, array patterns, and record patterns. We will cover everything in detail using the code examples. I have created a Java project, and in this project I am using Java version 21. I am using Java version 21 because we are also going to learn the pattern matching for switch expressions. The pattern matching for switch expressions feature was released as a preview feature in Java 17 and it was finalized in Java 21. So that's why here we are going to use Java version 21. In this project, I have created a class named as switch statement, and this class has one method which is getDname. As an input, this method is going to take the day number and it will return the name of the day of a week. Inside the getDayName method, we are using the traditional switch statement to get the day name based on the input, which would be the day number. Corresponding to every day, we have 7 case levels in the switch statement, and we have also added one default statement in the switch. If the input is between 1 and 7, then the day name would be returned, and if the input is less than 1 or it is greater than 7, in that case it is going to throw the exception, and that exception would be illegal argument exception. Here switch takes the day number as an input and it matches the day number with the case labels, and when the match is found then the case block would be executed, and if it is not found then the other case value would be matched. If no match found, in that case the default section would be executed and it is going to throw the exception. Inside the each case label, we are using the assignment operation. So at the beginning, we have created one temporary variable, which is day name, to store the name of the day. And inside each case label, we are going to assign the value to this day name variable. When control exits switch, then the day name would be returned. In this class, I have also created one main method, and in the main method, I have created an object of switch statement class, and here I am invoking the get day name and I am passing the day number. So here I am going to execute it. Here the day number is 1. In the output, you can see that the day name is Monday. In this code, I see 3 problems. The first problem is that the switch statement cannot return a value. So we have to declare the temporary variable, and this temporary variable would be assigned a value inside the case blocks. The second problem is that inside every case block, we are using the break statement to exit from the switch, which is ultimately increasing the boilerplate code. The third problem is the fall through behavior of traditional switch statements. By mistake, if we forget to add the break statement in the case block, then due to fall through behavior, we will get the incorrect result. So for that, let me do one thing. Let me remove the break statement from the case 3, and here I am going to pass 3. So if I run this code now, so here we can see that output is Thursday, but the expected output is Wednesday because the day number is 3. So output should be Wednesday. All of these problems are solved by the switch expressions. Let's understand how. For that, I'm going to copy this class and I'm going to create another class for switch expressions. Let me rename this class. The first problem was that the traditional switch statements cannot return a value, while the switch expressions return a value. So we do not need to use the temporary variable to store the name of the day. So I'm going to remove it. And then I'm going to use the return on the switch. In the switch expressions, instead of colon, the arrow syntax is used to separate the case label with case block. So here I am going to remove this colon. I'm going to replace it with arrow syntax. The second problem in the traditional switch statement was that we were using the break statements in every case block. In case of switch expressions, these break statements are not required. So I am going to remove all the break statements. I have removed all the break statements from the switch expression. Now I also need to replace the column with the arrow syntax. These switch expressions return a value, so we also need to remove this return statement from here, and here we need to use the semicolon at line number 14. In the traditional switch statements, the third problem was with the fall through behavior. In case of switch expressions, the fall through behavior is not supported, so it eliminates the requirement of break statements. And here every case block is independent from each other. Now I'm going to run it. So in the day name, I'm going to pass value 1. In the output, we can see that the day name is Monday. Now I'm going to compare both of these classes side by side. At the left hand side, we can see that the traditional switch statement is taking around 30 lines. While at the right hand side, we can see that the switch expressions are taking 13 to 40 lines. The code which we have written using the switch expressions is concise and expressive. In the switch statements, the default case is optional. So it is our choice whether we want to have the default case or whether we do not want to have the default case. In the switch expressions, the default case may or may not be mandatory. It will completely depend on the situation. Like if we are covering all the possible cases, then we do not need to define the default case. If we are not covering all the possible cases, then we have to define the default case. Here in the switch statement class, I am going to remove the default case from the get dayname method. At line number 29, we are getting an error, and the error is that the dayname variable is not initialized. So I'm going to initialize it with null. So in this class, we don't see any error now. If I run this, then see what is the output. So here we are getting null value as a day name, and we are getting the null value because we are passing 9 in the get day name method. Let's do the same thing for switch expressions. So from here I'm going to remove the default case. Here at line number 5 we can see that we are getting an error, and the error is that switch expression does not cover all possible input values. What does this mean? In this switch expression, we are having 7 cases which are going to cover values from 1 to 7. What if the value is greater than 7 or the value is less than 1? So in that case, the switch expression would not be able to identify what it has to return. So that's why it is giving the error. The only way to fix it is the default case, because we are going to receive integer values and the number of integers are used in range, so we are not able to define the case for every integer value. So in this scenario, the default case is mandatory. Let's take another example using which we will understand that the default case is not mandatory. So here you can see that I have created an enum named as status, and it has 3 values: active, inactive and pending. Inside the get status method, I am using the switch expression, and in the switch expression I have 3 cases. The first case is for active, and the second case is for inactive, and the third case is for pending to handle the status values. Here we are not getting an error because here inside the switch expression we have handled all possible cases for status values. In the status enum we have 3 values, and in the switch expression we have 3 cases. So we do not need to use the default case here. But if I remove any case statement from here, then we will get the error that switch expression does not cover all possible input values. So from here we can see that the default case is optional or mandatory as well. So here we can see that the default case may or may not be required in the switch expressions. If we have covered all the possible input values, then there is no need to define the default case in the switch expressions. If we are not covering all the possible input values, then we have to define the default case in the switch expressions. In the switch expressions, we can group multiple case labels. Using an example, we will understand why we need to group the case labels in the switch expressions. In the switch statement class, I have created one method which is weekend. This method is going to accept an integer value which would be the day number, and this method is going to return whether it's a weekend or not. If we try to achieve this using the traditional switch statement, then we have to utilize the fall through behavior which is supported by traditional switch statements. So here you can see that from line number 7 to 11 we do not have the case blocks, and we are not using the break statements in the case blocks. And at line number 12 we are going to assign the value false to is weekend. So if the day number is between 1 and 5, then it is not a weekend, and if it is 6 or 7, then it would be a weekend. And if the day number is greater than 7, in that case it is going to throw the exception that this is an invalid input. Here in the switch statement we can see that we are using a lot of boilerplate code. We are defining the cases from 1 to 5, and for these cases we do not have any blocks. And for case 6 and 7 we have the same thing. So the case 6 does not have any block, while the case 7 has one block. This can be simplified using the switch expressions. In the switch expressions we can group the multiple case labels, so that would reduce the number of lines in the switch statements. So in the switch expr class I have already copied that code, and now I am going to make these changes. So instead of these 5 cases I am going to use case 1, 2, 3, 4 and 5, and going to use arrow syntax. And we do not need to use if we can variable, because switch expressions can return a value. So here we are directly going to return the value as false, and we do not need to use the break statement. And here I am going to group case 6 and 7, and instead of colon I am going to use arrow syntax. Need to remove this break statement, and we also need to remove this return statement from line number 11. And the switch expressions can return a value, so we are going to return the switch expression value. And in the default case we also need to replace the colon with the arrow syntax, and we also need to put the semicolon at line number 9. So here we are done. I'm going to pass the day value as 2. Now I'm going to run it. So here we can see that this is not weekend. This is the output. And if I pass value 6 and I run it again, the output is weekend true. if I pass value as 9 and I run it again, so here we can see that this is throwing the exception, and which is illegal argument exception, and the message is that invalid input is passed. The switch expression is doing the same thing here, which we were trying to achieve using the traditional switch statement. In the traditional switch statement, the number of lines are around 19 to 20, but in the switch expressions, the number of lines are 6 to 7. In the switch expressions, we can define one case to handle null values. Let's see how we can handle null values in switch expressions. Here in the switch expression class, I have created one method named as getValue, which is accepting an argument of type object. And in the switch at line number 7, you can see that I have added one case to match the null values. So if the value is null, in that case, this case at line number 7 would be executed. If the value is the string, then the case at line number 8 would be executed, and if the value is an integer, then the case at line number 9 would be executed. And if nothing matches, in that case the default case would be executed. In the traditional switch statements, we can't do this. Even this feature is available in Java 21 only. This feature was released with pattern matching for switch expressions. So if we try to use this null value case in Java 17 or 16, then it would not allow us. Let's see what happens when I change the language label in IntelliJ. So here I'm going to use Java version of 15 instead of 21. Let me apply it. So here you can see that we are getting an error at line number 7, and the error is patterns in which are not supported at language level 15. As I told you that this feature is enabled in Java 21 only. Let's learn about the yield keyword, which is used to return a value from the case block. In the switch expressions, the arrow syntax is used to separate the case labels with the expression or case block. The left side of arrow syntax is called case labels, and the right side of arrow syntax is called expression or block. If the right side of arrow syntax has only single statement, then it is called expression. If the right side of arrow syntax has multiple statements, then those statements are enclosed in curly braces, and that is called block. The yield keyword is used to return a value from that block. Here in this screenshot, you can see that the first red box is representing the single expression, while the second red box is representing the block which has multiple statements. And using the yield keyword, you can see here that we are going to return the value. Here in the switch expression class, I have created one method named as get, and this get method accepts three arguments. The first argument is the operator, which can be either plus, minus, multiplication or divide, and then it is taking two arguments on which the operation would be performed. In the switch expression, we can see that we have defined case labels. We have one case label for plus operation, the second case label for minus operation, and the third case label for multiplication, and the fourth case label is for division. If the right side of arrow syntax has only one statement, then it is called single expression, and in this case there is no need to return the value using the yield keyword. If the right side of arrow syntax has multiple statements, then using the yield keyword, we need to specify that we are going to return this value. Here in the get method at line number 10, you can see that we are using a block and it is having multiple statements. For division operation, we are using the block, and in this block we have multiple statements. Before dividing the a by b, we are going to check if b is not equal to 0, then only division should be done. If it is equal to 0, then arithmetic exception should be thrown. So here using the yield keyword, we are going to return the value. When we have multiple statements in a case block, then we use this yield keyword to return a value. And this yield keyword is used in the switch expressions only. Here at line number 22, you can see that we are going to perform the addition. So we have passed the plus sign as an operator and two values 2, 3. So let me run this application and see what is the output. So here we can see that the result is 5 because 2 plus 3 is 5. If I pass 0 instead of 3 and instead of plus operation I pass the division. Let me run this again. So here we can see that we are getting an exception, and the exception is arithmetic exception, divide by 0. Till now we have learned what is switch expression. Now we are going to learn what is pattern matching for switch expressions. This feature was released in Java 17 as a preview feature, and it was finalized in Java 21. Before understanding the pattern matching for switch expressions, let us first learn what is pattern. Pattern is basically a combination of a condition and a binding variable. In the screenshot, the patterns are string s and integer I. String s is a pattern, and it's a combination of the condition and binding variable. Here condition is string and binding variable is s. Why string is called condition here? Because in this switch expression we can have multiple case values, and in each of the case values we can use different class names. These classes can be custom classes or Java classes as well. In this screenshot we have three cases and one default case. The first case is going to handle the null values, and the second case is going to handle the values of type string, and the third case is going to handle the values of type integer. If the value is not matching with first three cases, then the default case would be executed. Now let us learn what is pattern matching for switch expressions. Pattern matching is a process of matching a value against a pattern. In this screenshot, the selector expression is a value which we are going to match with the different patterns. And in this screenshot, each pattern is represented as a value in the case. The selector expression, which is passed as an input to the switch expression, will be matched with the first case. If the selector expression is null, in that case, the case block for null case would be executed, and if the selector expression is not null, then it would be checked whether this selector expression is an instance of string or not. If this is an instance of string, then its value would be casted into the string, and then its value would be stored in the binding variable, and here the binding variable is s, and this binding variable would be accessible within this case block. If the selector expression is neither null or it is not of type string, then the third case, which is integer, would be checked. So it would be checked whether this selector expression is of type integer or not. If it is of type integer, in that case it would be typecasted into the integer and its value would be stored in the binding variable I, and this value would be accessible within the case block. If the selector expression value is double, means it is not matching with any of these case values, then the default case would be executed. In the pattern matching for switch expressions, the value is automatically typecasted. We do not need to manually typecast the value into the particular type. Here in this screenshot, I have taken the patterns as string s and integer I. Here we can also use some custom classes like employee, person, customer. The pattern matching for switch expressions includes support for following patterns. The first pattern is type patterns, second pattern is guarded patterns, and third pattern is array patterns, and the fourth one is record patterns. In this video, we will cover each of them one by one. Let's learn about type pattern matching. The type pattern matching basically allows us to match objects based on their type and then bind them to a variable, and that variable is called binding variable. The type pattern eliminates the need for typecasting, which makes the code more concise and readable. The type pattern is very useful in the switch expressions when we are working with objects of different types. Here in this screenshot, we can see that the switch is taking the input variable as an input, and then it is going to match the type of input variable with the type pattern. If the type of input is matching with the type pattern, then the first case would be evaluated and the value of the input would be stored in the where variable and the expression 1 would be executed. If the type of the input variable matches with any of these type patterns, then that case would be evaluated and this input would be typecasted into that particular type pattern and its value would be stored in the variable and the corresponding case block would be executed. To understand the type pattern, I have created a class named as type pattern, and I have also created two classes named as employee and person. In the type pattern class, I have created one static method and its name is get message. The get message is going to take a value as an input of type object and then it will provide that value to the switch expression. The switch expression is going to check whether this person object is of type employee or person. If the person object is of type employee, then the first case would be executed and the person object would be typecasted into the employee and its value would be stored in the binding variable e. If the person is an object of type person, then the second case would be executed and the same process would be repeated. If the person is not an object of type employee and person, in that case the default case would be executed and that will throw an exception. Here in the main method, I have created two objects. One is for employee and the other one is for person. At line number 17 in the system.out.println, I'm going to invoke the get message method, and in the get message method I'm going to pass employee object reference variable. Now I'm going to run it. Here you can see that the case block of the first case is executed, and this is happening because in the get message method we are passing an instance of employee class. When this instance of employee class is passed to the get message, then switch is going to check whether this person is an instance of employee or this is an instance of person. As this is an instance of the employee, So that's why the case block for the first case is executed. So instead of the employee, if I pass person and if I run it again, so here in the output, you can see that the case block of the second case is executed, and which is I am a person object. This is the output, and this is happening because switch is going to check whether this person is an instance of the employee or person. As this is an instance of the person, so that's why the case block for the second case is executed. Let's see what will happen if I pass the null value. So I have already replaced the person object with the null value. So now I am going to run it. Here you can see that we are getting null pointer exception. In the switch expressions, we can define a case to handle the null values. So here I am going to handle the null values. So it is null. So now I am going to run it again. Here you can see that output is I am null. This is happening because the value is null and the first case is executed. Let's learn about guarded pattern matching. In the type pattern, we were checking whether the value is of a particular type or not. Using the guarded pattern, we can add additional conditions to the pattern match, and these conditions can be defined using the when keyword, and these conditions are called guards. This pattern is very useful when we want to match a value against a type and we also want to apply further checks to the value. The guarded pattern combines a pattern with the Boolean expression, and here this Boolean expression is called the guard. Here in the screenshot, the switch expression is going to check whether this input variable is of type pattern or not. If the input variable is of type pattern, then it will further check the other conditions. And those conditions are defined using the when keyword, and those conditions are called guards. In a single case, we can define multiple guards using the when keyword. To understand the guarded pattern matching, I have created a class named as guarded pattern, and in this class I have defined the static method named as classify input, and this method is going to accept a value of type object. In the switch expression, I have defined 6 cases and one default case, and these 6 cases are categorized into 3 categories. The first category contains the cases which are going to handle the integer values, and the second category contains the cases which are going to handle the double values, and the third category contains the cases which are going to handle the string values, and then we have the default case. Let's talk about the first category. In the first category we have two cases and both are going to handle integer values, but the first case has added the additional condition on the integer value, and that condition is that if the input is of type integer, then it should be an even number. If it is an even number, then only the first case block would be executed. If I is of type integer but it is not an even number, in that case the second case would be executed. If we want to define multiple conditions, then we can also do that by using the AND operator, and we can define the condition. That condition can be anything like, so here you can see that it is working. So I'm going to remove it. In these second category cases, we are going to handle the double values. So here we are going to check whether this input is of type double or not. If it is of type double, in that case we are also going to check whether its value is greater than 0 or not. If its value is greater than 0, so it means it's a positive integer, and if its value is not greater than 0, then the second case would be executed, and that will return the string as negative number at line number 13. In the third category, we are having two cases, and both of these cases are going to handle the string values. So the first case is going to check whether the input value is of type string, and if it is of type string, then it is further going to check is it empty. If it is empty, then it will return the message empty string, and if it is not an empty string, in that case the case at line number 17 would be executed. If the input value is of type character, in that case the default case would be executed. Inside the main method, I am going to invoke this classify input method. So first I am going to pass an even number, and I am going to run it. So here in the output you can see it's an even number, and if I pass an odd number, then so here in the output you can see that the output is odd number. Now I am going to pass a double value which is 3.0, and let me run it again. So on the screen you can see that the output is positive number, as 3.0 is a positive number. If I make it to minus 3.0, then its output would be negative number, and this can also be the string. So I'm going to pass the empty string and going to run it. So here you can see that the output is empty string. So here in this class we have defined the additional conditions using the when keyword. For the string empty check, we are using this s dot is empty, and to check whether the number is a positive number or it's a negative number, and for that we have applied this check which is d greater than 0. And then the first check is for even numbers and odd numbers. Here I'm defining only one condition using the when keyword. We can define multiple conditions as we want. Let's learn about array pattern matching. Till now we have learned about type pattern and guarded pattern. In the type pattern, the value was matched against its type, and in the guarded pattern, we have applied the guard condition along with the pattern. The pattern matching for arrays is not natively supported in the switch expressions in the Java, but using the type pattern and guarded pattern, we can implement this. The array pattern matching allows to match the arrays in a switch expression, and these arrays can be matched based on the length of the array, and we can also match these arrays based on the content of an array. We can also match the arrays based on their elements. Here in this screenshot, the getType method is going to accept an argument of type object array. In the switch expression, I have defined three cases to handle the integer array, string array, and boolean array. I have also defined one default case which would be executed when this array is neither integer array or string array or boolean array. When the getType method would be invoked, the switch expression is going to check whether the input value is of type integer array or string array or boolean array. If the value is of type integer array, then it is going to execute the first case block. If the value is of type string array, then it will further check whether this array is an empty array or non-empty array. So if it is an empty array, then the case block of the second case would be executed. If the value is of type boolean array, then it will check whether the length of the boolean array is 1 or not. If its length is 1, then it will further check whether the value which is stored in the boolean array is true or false. If it is true, then the case block of the third case would be executed. The default case would be executed when the input value does not match with any of these cases. To understand the array pattern matching, I'm going to use the example of food delivery service. So here I'm going to use two arrays to represent the delivery order and takeaway order. In the first array, you can see that the first element is representing whether the order is delivery or takeaway. So using the delivery text, we have specified that it is a delivery order, and in the second argument, we are passing the uh, price of the item. In the second array, the first value is a takeaway. So it means that it is going to represent the takeaway order, and the price of the order is 200. I will create one class which would be food delivery service, and in this class I will create one method named calculate total price, and this method is going to accept the delivery order or takeaway order arrays. And in this calculate total price method, I will use the switch expression to identify the delivery and takeaway orders, and this calculate total price method will return the uh, total price of the order. If the order is a delivery order, in that case the flat fees would be applied to the order, and if it's a takeaway order, in that case the packing charges would be applied. So here you can see that I have created one class named as food delivery service, and in this class I have created one method calculate total price, and the type of argument is object array. In the switch expression, I have defined two cases. So first case is going to handle the delivery order, and the second case is going to handle the takeaway order. And if the order is neither delivery order or takeaway order, in that case the default case would be executed. So let's talk about the first case. In the first case, I am going to check whether this order is of type string array or not. If it is of type string array, then I am going to check its length. If its length is 2 and the value of the first element is delivery, the case block of the first case would be executed. And here 75 rupees flat delivery fees would be applied to the order, and the total price of the order would be the order amount and the delivery fees. This second case would be executed only when the order is of type string array and the length of the array is 2 and the value of the first element of the array is takeaway. So in the second case, you can see that I have applied the packing charges only. So the packing charges are 20 rupees. So the total price would be calculated using the price of the order plus the packing charges. In the main method, you can see I have created two arrays. The first array is representing the delivery order, and the second array is representing the takeaway order. And then I'm invoking the calculate total price method for the delivery order, and again invoking the calculate total price method for a takeaway order. Using the println statements, I'm going to print the delivery order total and takeaway order total. So now I'm going to run it. Here you can see that the delivery order total is 275. This is 275 because the price of the order is 200 and 75 rupees delivery fee is applied. The takeaway order total is 220 because the order price is 200 and 20 rupees packing charges are applied. Here I'm using the string array only. So if we want, then we can also use the custom class arrays. So here in this package, I have created one class named as item. So here I'm going to define one case for this item array. Yeah, so here you can see that the code is auto generated for it. So we can also use the custom arrays. Here you can see that I have defined one more case, and which is uh, using the custom class array. Let's learn about records pattern matching. In the switch expressions, we can also use the record types. When in the switch expression the record types are used, then the object is matched against the record type, and if the object is an instance of a particular record type, then the components would be extracted from the object, and those components would be binded with the binding variables which we define in the case values. Here in the first screenshot, you can see that I have defined one record named as a delivery order. In this record, there are three components: order ID, item, and delivery address. In the second screenshot, I have defined one method named as calculate total price, and this method is going to accept the value of type object. As this value is of type object, so this can represent the array, or it can represent the record, and it can also represent the other custom classes objects. In the switch expression, I have defined two cases and one default case. The first case is going to handle the delivery order, and the second case is going to handle the takeaway order. If the order is an instance of the delivery order record, in that case, the first case would be matched, and the components of the order would be expected and would be saved in the binding variables. And the binding variables are order ID, item, and delivery address. To calculate the total price of the order, the accessor method of the item record would be invoked, and 70 rupees flat delivery fee would be applied. The item price and the flat delivery fee would be added to calculate the total price. If the order is an instance of takeaway order record, in that case the second case would be matched, and the components of the order would be expected and would be stored in the binding variables. And the binding variables are order ID, pickup time, and item. If the order is not an instance of delivery order record, or this is not an instance of takeaway order record, in that case the default case would be executed. To understand the record pattern matching, I'm going to use the example of food delivery service. In this example, I will create three records. The first record would be item, and this record will provide the price of the item. I will create delivery order record, and this delivery order record will contain three components. The first component would be order ID, the second component would be the item record, and the third component would be delivery address. I will create another record named as a takeaway order, and the takeaway order will have three components. The first component would be order ID, and the second component would be item record, and the third component would be pickup time. I will create one class named as food delivery service, and in this class I will define one method named calculate total price, and in this method I am going to pass the delivery order and takeaway order records instances. Using the calculate total price method, I will calculate the total price for delivery order and total price for takeaway order. As I have already explained the example of food delivery service. So here let's go through the classes which we talked about. We have already seen what records and classes would be required to implement the food delivery service. So here I have created three records. The first record is item, and it has two components, name and price. And the second record is takeaway order. It has three components. First component order ID, second component item, and the third component is pickup time. In the same way, I have also created the delivery order record. It also has three components. The first component is order ID, second component is item, and third component is delivery address. I have created 4 videos on records, and there I have explained about the records in detail. So if you want to learn about the records, then you can watch those videos. In the description, I will share the link for those videos. In the food delivery service class, I have created one static method named as calculate price, and this is going to accept an argument of type object. And in the calculate total price method, I have defined the switch expression, and in the switch expression I have defined one case to handle the delivery order record, and the second case to handle the takeaway order record. If the order is not an instance of delivery order or takeaway order, then the default case would be executed. In the first case, it would be checked whether the order is an instance of the delivery order record. If it is an instance of the delivery order record, in that case, the components of the order would be expected and would be stored in the binding variables. If the order is an instance of delivery order record, in that case, the first case would be executed, and the components from the order object would be extracted and would be stored in the binding variables. From the item binding variable, we can get the price of the order, and then in that price we can add the flat delivery fee, which is 70 rupees. If the order is an instance of takeaway order record, in that case the second case would be executed. Here in the main method, you can see that I have created two records. The first one is a delivery order and the second one is a takeaway order. And from this method, I'm going to invoke the calculate total price method twice. For the first time, I will pass the delivery order, and for the second time, I will pass the takeaway order object. And then using the println statements, I am going to print the delivery order total and takeaway order total. So now I am going to execute it. Here you can see that the delivery order total is 270 rupees and takeaway order total is 220 rupees. The price of the order is 200. For delivery order, 70 rupees delivery fee is applied, and for takeaway orders, 20 rupees packing fee is applied. In this project, I am using Java version 23 as the binding variables. Order ID and delivery address are not being used here. So here we can use the concept of unnamed variables. So instead of using the names for these variables, I can use underscore, as we are not going to use these variables. Same can be done with the binding variables of the second case. So we can replace with the underscore. That's it for this video. Please don't forget to like, share and subscribe, and please provide your comments in the comment section. Thank you.